Welcome all. Today let us discuss the frictional force. So, in the previous sessions we took the motion of or the dynamics of blocks moving over a smooth surface. Okay. Now, we are going to consider rough surfaces, that is frictional force also will be acting. Frictional force also will be acting on this block. So, what is meant by friction? So, we know friction is the force which comes into play when a body has a tendency to move over another surface or when there is a tendency for relative motion, right. That is, this is a surface, consider the top of a table, a block is placed on it. Initially the block is resting on it. Now, we slowly push it by applying a force. What will happen? A frictional force will develop, right. That force will oppose the relative motion. Now, when it is pushed in this direction, this block has a tendency to move towards right. It is sliding over this surface, right. So, this is a top surface of a table. So, it is sliding over this surface, the block tries to slide over this surface. Now, the surface in the sense the top of the table surface opposes the relative motion. That force is called what? Friction, or friction is a force which opposes the relative motion between two surfaces. Okay. Relative motion between two surfaces. Okay. So, in this case, this is the applied force on the block. The frictional force will be in the opposite direction. Okay. So, frictional force will be towards left, we can say. Okay. So, this is a block, we are applying force in this direction. So, the friction will be acting in this direction. Okay. Now, if you just place it on this, initially the block was on the table. Now, initially there is no force at all, meaning the block does not have any tendency to move over the surface. Now, friction also will not be there, right. Friction will not be there because there is no tendency for relative motion. If you slowly apply, see, start with 1 Newton force. Now, the block will not move. Again increase 2 Newton, the block again will not move. So, like this, see, let us say 10 Newton. When we apply 10 Newton force, suddenly the block starts moving. Okay. So, up to 10 Newton, the block will not slide. Why? Because the surface apply a force, the surface will apply a force in the opposite direction, right. That is what is a frictional force, meaning if you apply a force on it, the frictional force will develop. So, if you apply 1 Newton, frictional force also will be 1. This is applied, this is frictional force. If you increase to 2 Newton, again this also becomes 2 Newton. Again these two get cancelled, right, meaning applied force is in this direction, friction is in the opposite direction. So, like up to 10 Newton, the friction also will be 10 Newton. So, if you slightly increase this from 10, suddenly this block starts moving, meaning after that friction remains constant. Okay. So, what idea we will get from this? If we increase the applied force, the frictional force also will increase, but it will reach up to a maximum value. In this case, in this example, it is 10 Newton. After that, what will happen? The frictional force remains same, right. Now, the acceleration will be based on the applied force. Okay. If you plot a graph, applied force versus frictional force, see, this is applied force capital F, this is frictional force small f. So, as applied force increases, the frictional force also becomes maximum, then after that on increasing the applied force, the frictional force remains constant. Okay. So, like this, the frictional force, as applied force increases, friction also will increase. reaches to a maximum value, then while moving the frictional force will be slightly less than the maximum value. Okay. This maximum value is called limiting friction. Limiting friction. Okay. This is called static friction. Static friction. That is, up to this limiting friction, there is no motion at all. In our example, up to 1 to 10 Newton in this case, the example which we said already. So, up to 10 Newton, there is no relative motion. So, that is called static friction. So, after 10 Newton, the block will move. So, this is called kinetic friction. Kinetic friction. So, static friction is the frictional force before the motion starts, right. So, static friction is the frictional force acting on the block before the motion starts, and limiting friction is the friction just before the motion starts. Okay. That is, from this point to this point, it is static friction. The maximum value of static friction is limiting friction. Once the motion starts, the friction will be slightly less than this. Okay. That is a small curve over here. So, it will be slightly less than that, and after that the frictional force remains constant. That is called kinetic friction or sliding friction. Okay. So, static friction is the frictional force before the motion starts. Limiting friction is the frictional force just before the motion starts. Kinetic friction is the friction during the relative motion. Okay. Now, we can say that static friction is self adjusting friction. Self adjusting in the sense, in this example, see, when the applied force was 1 Newton, friction also 10. This is applied frictional force. Applied force was 1, friction also 1 Newton. When applied force increases to 2, friction also increases to 2, right. When it changes to 3, it will also change to 3, meaning that friction is what? Self adjusting. So, it is based on the applied force actually, right. So, the static friction based on the applied force here, it is self adjusting, we can say. Okay. So, it will reach the maximum, that is what limiting friction. After that, kinetic friction will be slightly less than limiting friction, and it will be constant. Kinetic friction is independent of the velocity. Okay. Kinetic friction means that will be a constant value independent of the velocity. Okay. So, now let us consider the motion of block over a surface with friction. That is, we are considering the frictional force also in this case. It is not a smooth surface. Okay. Frictional force will be acting on it. So, take it as a block of mass m, F is the applied force. So, we know frictional force will be there. If F is small, it will not move because of the static friction. Up to a certain value, there will not be any relative motion. That is, up to the limiting friction value, there will not be any relative motion. Once this applied force exceeds the limiting friction, then the block starts moving. Now, the friction force is called kinetic friction. The value of kinetic friction is kinetic friction F k, we can say, it will be equal to mu into normal reaction, where mu is called the coefficient of kinetic friction. Mu is coefficient of kinetic friction. Okay. So, that mu depends on the surface. Okay. Mu depends on the surface between this. Okay. And n is the normal reaction. Okay. And it is a normal reaction. So, in this case, what will be the kinetic friction? Mu into normal reaction is how much? We know it is on the plane surface, horizontal surface. So, here mu n equal to mg, right. Normal reaction equal to mg, that we already discussed. Now, what will be the during the motion, what will be the force equation? Once the motion starts, frictional force, kinetic friction will be acting. So, we can write F minus F equal to m a, right. F is the applied force, small f is the frictional force, that will be in the opposite direction. So, F minus F equal to m a, or F minus mu n equal to m a, F minus mu n equal to m a. This mu n will come into play during the motion, that is kinetic friction, that is the body starts the relative motion, right. After that only we can say that it is n equal to m g. Up to the motion or up to the limiting friction, the frictional force acting on the block will be static friction, that will be equal to what? Applied force. So, up to the value of the limiting friction, acceleration will be 0, right, because F and F will be equal in magnitude and opposite direction. But once the motion starts, what will happen? F will be mu n, or it will be a constant value. So, F minus mu n equal to m a. Okay. This mu n will be a constant value independent of the speed or velocity of the block. It will be constant, mu into normal reaction. Normal reaction, in this case it is m g, it will not be m g always, right, depends on the situation. Okay. Already we discussed the different cases of normal reaction, right. So, in this case it is what, just body is just on the surface, now it is m g only. Okay. Let us see an example. A 20 kilogram block is placed on a surface, mu equal to, take it as 0.1, mu equal to 0.1. Now, we are applying a force of F equal to some 200 Newton is acting in this direction, 200 Newton is acting in this direction. Okay. Now, what will be the acceleration? What will be the acceleration, friction and normal reaction? Acceleration, friction and normal reaction, these are the data we need to find. Acceleration, friction and normal reaction. Okay. We have the mass of the block, applied force and coefficient of friction. Okay. Take G equal to 10, take it as 10, G equal to 10. Okay. So, now let us see what is the maximum frictional force that the surface can act on this block, that is mu n, right, mu n. So, maximum frictional force F max is mu into normal reaction. What is normal reaction? In this case it is m g, right. So, mu into m g, mu into m g. So, mu m g, mu how much? 0.1, mass how much? 20, g 10. So, we will get 20 Newton, right. So, 20 Newton, this is the frictional force acting, maximum friction that the surface can act on the block. Okay. What is the applied force? 200. So, definitely the applied force is greater than the opposite friction. So, the block will move, right. So, the force, the free body diagram will be, this is mass m. So, applied force here how much? 200, and the opposite force here friction, right, how much? This is 20, this is applied force. We can write F minus F equal to m a, right, F minus F equal to m a. How much? What is F? 200. What is small f? 20, equal to 20 into a. Mass of the block is 20. Okay. So, 20 a. So, we will get 20 a equal to 180, right, or a equal to 9. So, we will get a equal to 180 by 20, that is 9 meter per second square. So, that will be the acceleration of the block in this case, and the frictional force is how much? 20. You are getting friction is 20, acceleration 9, and normal reaction how much we got? Normal reaction is m g, right. How much? M g means 200. Okay. This is what is the result we get now. Clear? So, in this case, suppose here we took applied force 200. Okay. Suppose in this case the same problem, if the applied force was only 10 Newton, the same problem we can analyze in different ways. So, mass is 20 itself, mu equal to 0.1, g equal to 10, take it as g equal to 10. Now, the applied forces some 10 Newton, let us say 10 Newton is the applied force. Okay. Now, what is normal reaction? N is mg itself, right? That is how much? 20 into g, that is 200. Take g equal to 10, so you will get 200. 200 Newton is a normal reaction. And what is maximum friction? F max how much? Mu into normal reaction, right? That is how much? 0.1 into 200, that is 20 Newton. This is the maximum value of the frictional force. But what is the applied force? Only 10. The applied force is only 10 Newton, but frictional force can go up to 20 Newton. What will happen to this block? What will happen? Friction will be towards left, applied force is towards right. The friction, maximum friction is 20. The block will not move in this case, right? The block will not move. You cannot say that due to frictional force it will move towards left. This is not the friction always. This is the maximum possible value of friction. Does not mean that the frictional force acting on this block is always 20. 20 Newton is the maximum mu into normal reaction, that is the maximum frictional force acting on this block, right. It does not mean that throughout the motion the frictional force is, throughout the cases the frictional force is 20, right. Here we have what applied force is 10 only, the block will not move. So, what will happen? The frictional force acting will be static friction. So, before the motion starts, the frictional force will be equal to the static friction, and that will be equal to what? Applied force. So, here the frictional force is 10 Newton only, not 20. This is the maximum possible friction. Here the block is not moving. So, frictional force is static friction, and static friction equal to what? 10 Newton. Static friction is equal to the applied force in magnitude, and that is equal to 10. So, the block will not move, right. So, acceleration is how much? 0, of course 0, right. So, here the maximum possible value is 20. It means up to 20 Newton, that is we increase the value of the applied force to 20, there will not be any motion. Up to 20 Newton there will not be any motion. That is, if the applied force is 1 Newton, frictional force will be 1, no motion, right. Applied force is 10, frictional force again 10, then also there will not be any motion. Applied force is 19, again the frictional force is how much? 19, static friction 19, again it will not move. So, up to 20 Newton the block will not move, but once the applied force becomes 21, the applied force becomes 21, what will happen now? Now, the block will start moving, right, because the friction can go up to 20 Newton only. Now, the block will be like this, the free body diagram will be like this, towards right 21, opposite friction 20. Now, there is a net force. So, what will happen? A net force of 1 Newton will be there in this case towards right. So, what will happen? The block will move with an acceleration how much? Net force will be 1 Newton, right. So, the acceleration will be how much? We can write F minus F equal to m a. So, F minus F is how much? 21 minus 20 equal to mass 20 equal to 20 into a. So, we will get a equal to 1 by 20, right. So, the acceleration in this case will be a equal to 1 by 20. Okay. Here the net force will be 1 Newton only. Clear? So, that is what is the way the friction acts on a block. So, keep in mind the friction is not a constant value, right. The friction is a force which acts, which develop or which appears to or which come into play when there is a relative motion between the two surfaces. The frictional force opposes the relative motion always. Okay. So, before the motion starts, the frictional force acting will be static friction. It will go up to a maximum value, that is called limiting friction. After that, if the applied force exceeds what will happen, the block starts moving. Now, the frictional force is called kinetic friction. The kinetic friction will be constant, independent of the velocity. The kinetic friction will be slightly less than limiting friction. Okay. So, static friction is self adjusting. It will be equal to the applied force in magnitude, but opposite direction. Okay. Now, let us see if we change the normal reaction, what will be the frictional force. For example, see, we have a block here, M is 20 Newton. We have a force 10 Newton acting downward, okay, and 200 Newton is in this direction. Applied force is 200. Now, what will be the normal reaction? See, we have downward mg and downward one more 10 Newton, an additional force 10 Newton is there downward. Normal reaction will be upward. We know n in this case will be equal to what? Mg plus 10, right. M is 20, take g is equal to 10 plus 10. So, how much? 210, right. 210 will be the normal reaction here. Take mu equal to 0.1. Okay. Now, what is the maximum frictional force? F max equal to mu into n. See, now the normal reaction is 210. Okay. So, how much? 0.1 into 210. So, it will be 21, right. So, it will be 21. See, normal reaction is not always mg. Okay. So, normal reaction may vary, depends on the situation, right. When there is an additional force on this block, normal reaction will be different from mg. Now, the equation will be F minus F equal to ma. The block will move, right, because friction is how much? Only 21. Applied force is 200. So, definitely the block will move. So, the kinetic friction will be acting. So, how much? 200 minus 21 equal to 20a. So, you will get a equal to how much? 179 by 20. So, this will be the acceleration, right. This will be the acceleration in this case. Okay. Now, let us see the motion over an inclined plane, motion over a rough inclined plane. See, smooth inclined plane we have discussed already. We know the acceleration is how much? G sin theta, right. Here we have a block here. The friction is, this is surface is not smooth, frictional force will be acting now. Now, downward force will be there, that we know, it is mg sin theta, right, mg sin theta. The frictional force will be acting in this case upward. If the block is trying to slide down, frictional force will be upward. If we pull the block up, frictional force will be downward. Okay. The resolution of this mg sin theta and mg cos theta and all we know, right, already we said. So, there will be a normal reaction here and mg cos theta will be here. The resolution of this we discussed already in the previous session. So, here the when the block starts sliding, what will be the frictional force? The maximum value, right, that is how much? Mu into n. What is n in this case? Mg cos theta. So, mu mg cos theta will be the friction. Now, when the block slides down, what will be the acceleration here? A equal to, see, net force how much? Downward mg sin theta. Due to this mg sin theta, the block is moving, sliding down, and upward is how much? The friction, how much? Mu mg cos theta. So, this will be the net force on this block along the plane, right. So, along the plane the net force on this block will be mg sin theta minus mu mg cos theta. Okay. So, the net force will be always equal to what? Mass of the block into acceleration. So, what is A? This get cancelled, right. So, we will get m get cancelled. So, we will get g into sin theta minus mu cos theta, right. So, this will be the value of acceleration. So, A equal to g into sin theta minus mu cos theta. Okay. So, this will be the acceleration in the case of a rough inclined plane while sliding down. Okay. When the block slides down along a rough plane, rough inclined plane, the acceleration will be g into sin theta minus mu cos theta. What was the result on a smooth inclined plane? Do you remember? Our result was g sin theta, right, because the mu was not there, mu was absent, right, because in the case of smooth surface we have no mu friction. So, if you take mu equal to 0, you will get g sin theta. Okay. So, on a rough surface while sliding down, it is A equal to g into sin theta minus mu cos theta. Clear? So, to start, actually in this case, to start the motion, the mg sin theta should be greater than friction, right, or mu into mg cos theta. Here the applied force means mg sin theta, downward force is mg sin theta here. So, due to mg sin theta, the block slides down, the friction, upward friction opposes mg sin theta. Okay. In this case, see, if there is a sufficient friction to block the sliding motion, if the friction is sufficient to block the sliding motion, what will happen? See, that is, the block is placed on the plane, definitely mg sin theta will be acting and friction will be there, and we know friction is not a constant quantity, right, it will increase, that is static friction will that is self adjusting. So, it will increase up to a limiting value, then after that only it remains during the motion, or once the motion starts it will be constant, but up to that it will vary, right. So, see, if the frictional force, upward friction is sufficient to block the downward mg sin theta, what will happen? The block will not move. Now, the frictional force will not be mu n, right. What will be the value? It will be mu, it will be equal to the applied force. That is, in this case, when a block is placed on the surface, just placed on an inclined plane, and the block is not sliding, now the downward mg sin theta will be opposed by the applied frictional force. Now, F will be equal to mg sin theta. F will be equal to mg sin theta. This will happen if the block is resting on the surface, it is not moving down. Okay, it is not moving down, it is just placed on its inclined plane. So, downward force will be mg sin theta, upward force will be friction. So, it will be the static friction, right, it will be static friction. So, it will be it is self adjusting. So, downward mg sin theta will be equal to what? Upward frictional force, that is why the block is not moving. To start the motion, the downward force just balance the applied force, or should be greater than the, sorry, not balance applied force, the frictional force, or it should be greater than the frictional force, then only the block will slide down. Or to start the motion, or while sliding down, the mg sin theta should balance F, or it should be greater than F. Okay. One more point I will add here. So, angle of repose. Angle of repose means, see, if you place, when a block is placed on a horizontal table, it will stay there, right. If you slightly increase the inclination, again the block can rest on it, but if you increase the inclination, what will happen? At a particular moment, the block will start sliding down. That particular angle is called angle of repose. That is, a block is placed on this horizontal plane, you are slowly increasing that plane or increasing the angle. What will happen? At a particular angle, the block will start sliding down. That angle is called angle of repose. What is happening here? See, when the block starts sliding down, the downward mg sin theta will just balance the friction. We know it is sliding down. So, the friction is how much? Maximum value, that is mu into normal reaction, that is mu into mg cos theta, right. It just sliding down means no acceleration, it is just sliding down with constant velocity. So, mg sin theta minus f equal to 0 or mg sin theta equal to f or mg sin theta equal to mu mg cos theta or tan theta equal to mu, right. That is, g get cancelled, m also. So, sin theta by cos theta becomes mu. So, tan theta equal to mu. This angle is called, this theta is called angle of repose. So, tan of angle of repose will be equal to mu. Okay. Tan of angle of repose will be equal to mu. That is, angle of repose means it is the inclination of the plane when the block just starts sliding on the plane. Okay. The angle of inclination up to which the block just starts sliding on it, that is, that angle is called angle of repose. So, at the angle of repose, the downward mg sin theta will be equal to the upward friction mu mg cos theta. Okay. Now, we will get the result tan theta equal to mu. Okay. I hope you understood this. Okay. Thank you.